Okay, students, Mod 3, Topic 2, Lesson 2, page 547, the tangent ratio. So remember, we've already mentioned SOHCAHTOA in the prior video. You know how to spell that correctly. And so tangent is right there, the T. And so we know tangent is opposite over adjacent. So that's what we're focused on here. Next, you see lesson 3 is the sine ratio, which right here is sine, so opposite over hypotenuse. Lesson 4, the cosine ratio, adjacent over hypotenuse. Okay, so we're just taking one at a time right here per lesson. So that then she could give you more time to work on your mathia afterwards. Normally in a book, you'd have all 3 of those in one lesson. This book is choosing to expand it out. Okay, so let's go ahead and look down here. There's having you put these on a calculator, make sure you can put in the calculator. So if I bring up the graphing calculator, okay, let's see if I can move this to the side so we can still see that right there, right like that. And so I have the square root of 3. I hit the right arrow to get out of that, divided by 3. And hit enter. And there you go. 0.57. It says round to the nearest hundredth. In other directions, 0.58. Okay, notice right there it says nearest hundredth. And the last one we're going to do is number 2, because 3 and 4 are the exact same, just different numbers as 1 and 2. So now we do 2 root 3. So I hit 2 square root 3, hit the right arrow to get outside of it, hit enter, and I get 3.46. Okay, let's go ahead and go on now. All right, consider these. Here's our 36, 90, 45, 45, 90. Okay, remember these are called special right triangles. You should know that. And we know since this is 90 right here on all these, that the other 2 angles are complementary, meaning they add to 90. That's how it's easy to quickly get the other ones. As a quick reminder on a 30, 60, 90, you should already have it memorized by now. The relationship is A root 3, and 2A. Okay, now you can see it on the board. On a 45, 45, 90, obviously 45 and 45 are the same. So it's got to be A and A, or whatever variable you choose to use, and the hypotenuse is root 2 times longer. You've been doing these in your warm-ups as well, solve them for them. Okay, so that's just a quick reminder of that. Okay, so here's an example. It says the maximum incline for a safe wheelchair ramp should not exceed a ratio of 1 to 12. Okay, so however high it is, it needs to be 12 times as long as that. Okay, says this means that for every one unit vertical rise, it requires 12 units of horizontal, 12 times as long. The maximum rise for any run, so rise would be the Y, for any run is 30 inches. Okay, down here I just made up my own numbers here. Okay. The ability to manage the ramp's inclines relates to both its steepness and its length. The Americans with Disabilities Act specifies the maximum incline for a safe wheelchair ramp. That's who says that. Okay, so it says the max rise for any run is 30 inches. So the max rise, let's say that was 30 inches. That's the max rise it can be, right? It says the max rise is, remember, means that for any run. Well, if it's going to be 30 inches, we know, remember, the maximum incline should not exceed a ratio of 1 to 12. This means for every unit of vertical, it has 12 units of horizontal. So if I do 30, oh, that's where I just changed it into feet. 30 inches is 2.5 feet. That's what I did. I just converted inches to feet. Maybe down here it asks in feet. Oh, okay. So they changed it to your feet down here. Okay, that's why I had done that before. Okay, so 30 inches. If the length has to be 12 times long, that'd be 360 inches, right? Because it's got to be 12 times long, ratio 1 to 12. So how many feet is 360 inches? So you're dividing 360 inches by 12 inches per foot. So then when I'm done, I get 30 feet. 360 by 12 is 30. So that equals the 30 feet. Okay, and I converted that because down here it talked about feet. Okay, so now how long would that ramp have to be? We just include that, the drawing line conclude the length of the ramp on B here. So since I have two sides in a right triangle, okay, I can use Pythagorean theorem. So I have a squared plus b squared equals c squared. Doesn't matter which one I call a and b. Okay, so we're going to use the feet 2.5 squared plus 30 squared equals c squared. 6.25 plus 900 equals c squared. So 906.25 equals c squared. Take the square root of both. So c is approximately equal to, and does it tell us what to round to at all? No. So you can never round up in real life if it has to be in those conditions. So I'd have to round down when I'm done here. Okay, so square root of 906.25. Square root of 906.25. Get out of there, hit enter. So 30.1. I can't ever go up because it has to satisfy those conditions. If I went up, that would now not satisfy it. So just know that 30.1 feet. Learn feet here. Let's bring it back up here. So approximately 30.1 feet would be how long that ramp would be. Okay. Let's go to some. Okay. So tangent now. The tan of A means the tangent of angle A. Okay, so when you see that. Vocab, I'm going to add some other vocab words in here. Okay. Here it tells you the tangent of an acute angle of a right triangle. We're always dealing with right triangles when we're talking about SOHCAHTOA. Is the length of the side that is opposite the reference angle to the length of the side that's adjacent to the reference angle. Okay, so this, remember, here's our 4 quadrants. Let's change the color so it sort of stands out. There's my X and Y axis right there. When I draw that right there, this side right here is called the terminal side. It starts at 0. We can remember it goes up to 90, 180, 270, 90 degrees each time, and then back to 360. Okay, so you're always starting at 0. I go up, if it ends right here, that's called the terminal side for like ending side. Between the terminal side and the x-axis, this right here is always the reference angle, which is why it's pointed to that right there. Okay, so this is the angle we're always referring to. Here would be the opposite or across from. Remember we talked about across from. Like I said, get used to saying the word opposites. Now is where we're going to use that word opposite. Over adjacent, which means next to. How do I know which one is adjacent? Well, this one is always the hypotenuse. The hypotenuse never changes, always across the 90-degree angle. So you identify the hypotenuse first, and then the 2 legs can only be the opposite of the adjacent. Obviously, the adjacent will be the one touching that reference angle, and the one opposite will be across from it or opposite of that angle. Okay, so there's your vocab. So again, remember we had tangent and TOA, and that SOHCAHTOA that we already wrote down. Tangent is opposite side over the adjacent side. Okay, so over A, opposite over adjacent. Okay, so just know that. There are SOHCAHTOA, spelled out again, sine, cosine, tangent, and what each one stands for. Okay, and we're using, consider A is in the right triangle below. So A is then called our reference angle. So that's why when we identify the hypotenuse first, you can call the adjacent side the one that touches it. So that's right here is adjacent, and obviously across from it is the opposite. So in this section, we're just doing opposite over adjacent each time. Okay. Another way of naming that side, I could have called it little a because it's across from big A, and I could have called this little b because it's across from angle B if I call it by one letter. But if I call it by the segment side itself, you notice that one is called BC. That's why they have BC there, opposite over the adjacent, which is AC. Okay, so there's your ways of naming those sides, and of course that would be AB, segment AB for the hypotenuse. Or I could have called it little c, across from big C. Remember, the side lengths are always lowercase letters, angles are always capital letters. Okay. So now we're just going to, okay, so now cotangent is just the reciprocal of that. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite, the reciprocal. Okay, and tangent and cotangent sound alike. So it's easy to put those together. They must be related. So tangent, uniform SOHCAHTOA is opposite over adjacent. Cotangent would be the reciprocal of tangent. So adjacent over opposite. Okay, now on the calculator, there is no cotangent. So remember, it's a reciprocal. So one way of doing the reciprocal is 1 over the tangent of A. That's the reciprocal. Or, and remember, that's what x to the -1, this button right there means, is reciprocal. So if I did tangent of, well, first off, mode. Just so you know, if we were calculating degrees, I mean, we were calculating the angle measure, which we're not to yet, we'll be coming up on it. I need to change the mode, hit the mode button next to that second button, and change it to degrees. By default, it's in radians. Okay, then I do second quit, come back here. So now if I wanted the tangent of, say, 30 degrees, there's the tangent of 30. If I wanted the cotangent of 30, I would hit x to the -1. It's going to do the reciprocal of that, and it'd be 1.73. So that's how you can do the reciprocal, as opposed to you having to type in 1 divided by tangent of 30, and you see you get the same answer. So 1 divided by tangent of 30 is the same thing as 30 degrees, the tangent of 30 to the -1 power. That's the reciprocal button. We call it the reciprocal button. Okay. All right, so let's look at this problem right here then. Okay, determine the tangent and cotangent values of both acute angles in angle DEF. Leave your answers as exact values. Exact, that means no decimals. That means you leave it in radical form. But remember, no radicals in the denominator. We've been practicing on your warm-ups. So to determine the tangent and cotangent of both acute, remember acute means between 0 and 90. So that's the 30-degree side and the 60-degree side. So if I do angle D, if I do tangent of D, or tangent is opposite over adjacent. So opposite, would identify the hypotenuse first, over adjacent. So I have 24 over 24 root 3. Okay, the 24 is canceled, so I have 1 over root 3, but remember, no radicals in the denominator, so I must rationalize it. This is where your warm-ups come in that we've been doing. Root 3 over 3. Okay, now the cotangent of D, remember, this is the reciprocal. I don't have to do the reciprocal of the last one. I can do the reciprocal of any one along the way. So once I get to that 1 over root 3, let's just do the reciprocal of that, root 3 over 1, which then equals root 3. Okay, so that's the tangent, cotangent of D. Now let's go ahead and do it of E. So tangent of angle E. So now, since we're using E as the reference angle, this is the adjacent, and that's the opposite. The hypotenuse never changes across from the 90-degree angle every time. You better be able to tell me that. First one you write down. Tangent of E, 24 root 3 over 24. 24's cancel, and you get root 3. And the cotangent of E would be that reciprocal. The reciprocal of root 3 over 1 is 1 over root 3. Remember, I can't have a root in the denominator, so I rationalize it. Multiply root 3 over 3, multiply straight across, and I get root 3 over 3. And there's my answer. So now if we compared them, notice the cotangent of D equals the tangent of E, and the tangent of D equals the cotangent of E. Okay, not that you need to remember that, but they'd like to just see if you can see a relationship, how they're the same. Okay. Here's that wheelchair ramp. Okay, so remember that it have to be 12 times long, so 24 times 12. 24 times 12 is 288. Oops, dropped the wrong one. So this has to be at most 288 inches. Okay, it can't be more than that. It can be less than that, but it can't be more. What information about the ramp is required to show the ramp meets the safety rules? It has to be less than or equal to 288. Okay, because it got to be 12 times. Write a decimal that represents the greatest value of the slope of a safe ramp. So the greatest value, remember changing y over changing x. Changing y is 24 over changing x, 288. Okay, so I go 24 divided by 288 on the calculator. 24 divided by 288. 0.083 repeating bar. 0.083 repeating bar. Exact answer. It can't be any greater than that. I type, yeah, 0.083 repeating bar. Okay. Use technology to calculate the value of tangent of 4 and use that value to determine whether the ramp meets the safety rules. Round your answer to the nearest hundredth. Okay, so now we're going to do tangent. So now we're going to calculate what the tangent of 4 degrees is to see if that actually you can have a 4-degree one. So the tangent of 4 equals the opposite, 24 over the adjacent. You can always put over 1 and cross multiply. So I get 24 equals x tangent 24 divided by tangent 24 on both sides. Tangent 24 is just like a number, like 5. Okay, it's going to give you some decimal. Okay, so now x equals whatever the exact answer is, 24 divided by tan 24. But of course, as it says, put in a calculator, round it. Okay, and to the nearest hundredth, we're going to go. Okay, so 24 divided by tan 24. 24 divided by tangent. Was it tangent 24 again? Yeah, tangent 24. 53.9. So is that less than 288? Yes, it is. So that definitely satisfies. It's less than a 288. Okay. Oh, right. Go back here for a second. Right. For that 1 to 12. Let's read it. Not to exceed a ratio of 1 to 12. So it has to be at least 12 times as long. It can't be less than that, so it doesn't exceed it. I mean, so it doesn't satisfy it. Sorry, I read it incorrectly. Okay, 1 to 59, 4 to 59 is not even close. It needs to be at least 288, not less or equal to 288. It's got to be greater than equal to 288. Where do I have that problem? need to be greater than or equal to 288. So it would be satisfied, and this was only at 59. So it does not. Okay, those are all the same type. Candidate ratio. Okay, try to get something new here. When the side opposite the acute angle measured 90 minus x in the smaller triangle is of length. Okay, so what this is talking about right here. 90 degrees, if we call this x, then we know this must be 90 minus x because we know those two are complementary. So these are called complements of one another, vocab words. Complements, meaning they add to 90 degrees. Okay, so if you see that, x and 90 minus x, those are complements in a right triangle. Vocab. Okay, inverse tangent. Inverse tangent, also called arctangent, is when you calculate the angle measure itself. And how you do that on your calculator is the tangent to the -1. You don't call it tangent to the -1, you call it inverse tangent. Okay, that's why you pronounce that. Inverse tangent is how you pronounce that right there. Okay, so let's go ahead and do that. Determine the measure of angle A. So that's what we want. Since we supposedly only know tangent so far, even though we've talked about sine and cosine already, we're only doing tangent in this lesson. We know the tangent is opposite, so there's our hypotenuse, opposite over the adjacent, so 15 over 10. So the tangent of A equals 15 over 10. Well, I need to solve for A, the angle A, so I have to get rid of tangent. The way you get rid of tangent is arctangent. They cancel each other out. Whatever you do to one side, you must do to the other side. And that's why you see that right there, so they cancel out. So A equals whatever that is in your calculator. So let's show you how you plug in the calculator, and you should get 56.31. Second tangent, what was it of again? 15 tenths. 15 divided by 10. 56.31. Just like we got right there going to the nearest hundredth. Okay, so this is how you calculate. And now they want you to do it from B. So you should see you get the same answer. Okay, so now if I make B, that now this is the opposite and this is the adjacent. So now I'd have tangent of B. So we know this is 56.31. We know this is complementary. So if I go 90 minus 56.31, that would be angle B. That's what I should get when I do the tangent of B equals 10 over 15. So I do inverse tangent on both sides to cancel out the tangent on the left. And so if I go inverse tangent of 10/15ths, I should get whatever 90 minus 56.31 is. So 90 minus 56.31 is 33.69. So that means when I do inverse tangent of 10/15ths, I should get 36.69. 33.69. 33.69. This probably need to flip back and forth instead of just having the calculator right next to you. Okay, so let's put in the calculator now. Inverse tangent of 10/15ths. Inverse tangent of 10 divided by 15. 33.69 right there. Exactly what we got. Okay. So that also would mean that we calculated this one right. Okay. That's the second way that you could check to see that you got it right. Okay. Let's go ahead and do this one right here. Solve for x. So again, we have tangent. We know we're using tangents already in here because it's the opposite over the adjacent. There's your hypotenuse. Those are two given to me. 37 over 85. So inverse tangent of both sides. And put in the calculator now. Inverse tangent of 37/85. Inverse tangent of 37 over 85. 23.52. There you go. Okay, that's covered all three types that were in here. Let's go ahead and if we do this, notice we have two of the three sides, so we can use Pythagorean theorem here. You don't always have to use tangent or inverse tangent. If they give you two of the three sides, go ahead and use Pythagorean theorem. A squared plus b squared equals c squared. Okay. All right, that goes ahead and does it. Here they're saying write a term for each description for angle EFG. So EG in relation to angle G. So that means angle G is your reference angle. What is EG? That's the adjacent over EF. That's the opposite. Adjacent over opposite, we should know, is cotangent. EG over EF in relation to angle G. It's the same thing. I don't know what that must be an error on the second one. Okay. And if I do inverse tangent of EG over, yeah, forget this right here. All right. So tangent and cotangent are reciprocals. An inverse tangent, remember, is used to find the angle measure. To find the angle measure. All right, 27 minutes.